a set of RDF statements. RDF stands for Resource Description and Framework, and it is a high-level definition of how to create these statements. Here is a simple an example of such a statement. Decameron's author is Boccaccio. It comprises 3 parts: subject, predicate, and object. All of the statements look like this. And there are some rules how to formulate these statements. The subject and predicate must be a URI, and the object can be a URI or a literal, a character string. Now let me give you a more concrete example. RDF is a high-level definition, and it is implemented in many ways. One is an XML, so it can be expressed in XML, but it can be expressed in Turtle and RDFA and in other ways also. Now this is an XML example in which the subject of the statement is a URI, as you can see here in red. Okay, this is, which is an identifier in the form of a URI, and it identifies the work of Decameron. And we state that it has an author. And as you can see, the predicate has also the form of a URI. And here is the object, which is also a URI, and also actually an identifier of a namespace record about Boccaccio. I copied here the namespace record, and in this record you can learn what the name of the person who created the Decameron, and you can get back other information as well. This year of the person, the birth year of the person, and other things. Here you can see in full the statement. The red is the subject, blue is the predicate, and the light brown is the object. And as you can see, the statement is comprised from URIs. Here is the same statement, a little bit formulated a little bit differently. You can see this statement more frequently, but you have to know that this is always an abbreviation. So DC terms colon creator is an abbreviation of this URI. I listed here some statements, some predicates from the previous pages. DC terms creator, BIBO document. In order to be able to make statement, you need words, very well defined words. These words come from element sets. These element sets usable for describing certain aspects of the real world. For example, the DC terms element set is suitable for describing metadata of objects. The BIBO element set is suitable for describing objects usually collected by libraries, and it contains words like document and article and journal and things like that. The web is similar to a document, and the semantic web is similar to a database. This is another metaphor. And it is also a very huge difference. The document is suitable for human being to read, and the database is for machines. And the RDF is the format of the database, as we have already learned it. And this database is independent from any application, which is also a very important characteristic of semantic web. Even the SQL databases are vendor-specific. But in this case, the semantic web, the RDF statements are, let's say, community, the internet community specific. The web was created for humans, and the semantic was created for machines, and I think I don't have to explain this. We can also state that the linked data can provide a uniform access mechanism. In other words, the linked data can be considered as a worldwide API. We have APIs for different programs, and all of these API is an application program interface. And if you know the API, you can use a distant, let's say, database, and you can get data back from that database. And, but all of these APIs are different, are proprietary to the system. So you have to learn the rules of each API, and then you can communicate the distant system. But in case of semantic web, there is just one API, which is the RDF. Semantic web is also good because they invented a lot of technologies which can be used not just semantic web purposes, but other purposes as well. For example, the data is stored in a triple store, and the language of the triple store is SparkQL. The retrieval language of triple store is called SparkQL. It has the same function as SQL in case of SQL databases. But SparkQL is a very powerful retrieval language. So, for example, the National Széchenyi Library uses triple store and SparkQL to retrieve all editions of a certain work. And I have just learned recently that Oracle uses prov to track changes over time for metadata from heterogeneous systems. What is prov? Prov is an element set, and even more, it describes how to handle this element set of provenience information, which is a long-weighted element set in the semantic field. I can give you an example. For example, Oracle has keeps track of persons with which Oracle has a connection, and imagine that a person who was a customer in the past now is the employee of Oracle, and in traditional systems it creates complication. But in the prov, with the help of prov, these situations can be handled very easily. Why is good semantic web for the cultural institutions? The data of cultural institutions can be shared by means of generally used tools. Libraries, for example, are very practiced on cooperation. They like cooperation, so they created MARC to exchange data. They created Z39.52 and SRU to search distant databases. But these protocols and formats are not understandable outside the library domain. And in case of semantic web, if you publish your data in the cloud, then everybody will understand your data. The cultural data can have a new meaning in this environment because it can interact with data from other domains. And it is worth mentioning that it is relatively easy for the cultural institutions to publish their data on the semantic web because the data in this domain are very segmented. So it is very easy to make statements. The semantic web has a task for the library, the cultural institutions, and has possibilities also. The task is to publish the data from the point of view of building the semantic web. And the software company is responsible for creating semantic web applications. And the possibility is that cultural institutions can use semantic web technologies, as I had already mentioned that. And the data of the cultural institution not just enrich the semantic web, but the cultural institutions can use the semantic web to enrich their own data. For example, on an OPAC, an author is displayed, and clicking on that author, we can get lots of information from the semantic web. You can invoke even the biography of that author or anything which is available on the semantic web. Now, I would like to speak about the presence of cultural institutions on the semantic web. I start with libraries. 2 libraries has already published their entire catalog on the semantic web. First was the Libris, the Union Catalog of Sweden, and the second was the National Széchenyi Library. There are lots of bibliographical data, but the libraries that I mentioned in the lower part of the screen, in the British Library, the Deutsche National Bibliothek, and the Spanish National Library just published parts of their catalog. But I would like to concentrate now on the museums. I mentioned the museums in the order I learned that they are on the semantic web. So I start with the Yale Center of British Art. They published the full collection. They are also a great supporter of open data. Even the highest resolution pictures can be downloaded free of charge from this site. The second museum I learned that on the semantic web is the Smithsonian American Art Museum. They also published their full collection, and they made links to the DBpedia and the Union list of artist name. Yeah. And it is worth mentioning that both museum are TMS users. TMS is a content management system used by the Museum of Fine Arts, my museum. Then I learned that Museum Finland also published their data, the Amsterdam Museum also. In Japan, more than 100 museums appears on the semantic web. And as far as I understood well a remark of my colleague, it is a government rule in Italy for the cultural institutions to publish their data on the semantic web, and this page is where all of these data sets are collected together. And last but not least, the British Museum also published their data. The entire online collection can be found on the semantic web. Speaking about the semantic web, we can't avoid to speak about Europeana. Europeana has a data model, the Europeana, which is called EDM, and it is based on semantic web. It's an interesting thing that although Europeana is based on semantic web statements, it still uses Solar, which is a free text search engine to get back the data. So Europeana is halfway of a fully implemented semantic web application, to be a fully implemented semantic web application. Now, as I have already stated, the semantic web is for machines. They can read the data, they can combine this data, but this data can be made visible for human beings as well. There are 2 ways of that. One is via HTML page. This URL is the URL of an OPAC record of the Yale Center of British Art. And here is the OPAC record. And now I magnify the top part of the screen. You can see the title and the creator of the painting. And on the bottom of the screen, you have the link to the RDF representation of this OPAC record, which is a lots of RDF statements. The machines are very happy to read this. For me, it is very difficult, although some parts is readable for the human beings as well. The other way is to communicate with a semantic web dataset is to use a SparkQL endpoint. Here is the SparkQL endpoint of the Yale Center for British Art, and here is a SparkQL question. very easy to read, and the result is also the statements. Now there are semantic web browsers also existing on the web. Here is the list of them. I installed the OpenLink Data Explorer on my machine, and this is the interface of that. I put here the identification number of, or identification URI of the work Decameron, and you can get the statements. It is able to display the statements in different ways. This navigator way is the most human readable, and now I can demonstrate how an object of a statement can be the subject of another one. So I'm clicking here. Where is the mouse? Clicking here, I get all the information about Boccaccio. And now, as you can see, the subject, all of these statements is Giovanni Boccaccio. And interestingly, it has an external link to DBpedia. Where is the mouse? Here it is. So if you click here, I can go to DBpedia, where I can get more information about Boccaccio, including a picture of him. Now I would like to speak about some semantic search application. One is a pilot project which was part of the European Connect project. And these are the actors that took part in this project, 3 museums, Louvre, Rijksmuseum, and RKD. And there are other data sets that were involved, mainly the Getty Thesaurus and also the Union List of Artist Name. And here is the interface of this search engine. The keyword is Egypt. And as you can see, the search result is presented in groups. So the software analyzes the search results and decides which groups can be created. Okay, if I hide the pictures, you can see the groups more clearly, and I magnified it for you to be able to read. So these were the groups that the software was able to create it. And I think it is an intelligent way of presenting a search result. Research Space is a current project, and it also aims to make the search more intelligent. This is the interface of this current project, and in this URI you can see a video which explains how this search will work in the future. And this site looks like an ordinary website, and it is, but we know that there are semantic data behind it. Probably there are so many relationships and so complicated relationships between matches and footballers and scores and everything that it was much more easier to express it in a semantic way. Now, I hope that you are eager to publish your data. How to do that? The first step is to convert your data into RDF statements. You have to choose the element sets with which you can express your statements. There are 2 obvious choices for museums. One is the EDM data model, and the other is the CRM element set. Then you have to create external links, because it is mandatory. It helps the machines to explore the semantic web starting from your data. And then you have to load the statements into a triple store. There are lots of triple stores available, Jena and Virtuoso. I just mentioned these two. And then finally you have to advertise that you have already published your data set. And the central point of this is that datahub.io, which publishes the well-known linked open data cloud. And certainly you have to publicize your data on your own homepage, and you can make available your data set as a downloadable file. And email it to the world, for the human beings also, to make them know that you exist on the semantic web. Now, I put some useful information here. This article, this is mandatory to read, and there are lots of tutorials how to publish your data. The National Széchenyi Library followed this tutorial step by step. And finally, I would like to mention that the Museum of Fine Arts has already decided to take part in a project aiming to publish the metadata on the semantic web. If we win the support from EU, then we will do that.